We are moving to the second half of Chapter 5 now. So 5.1 to 5.3 went together with the quiz. Now we're going to do the same thing with 5.4 to 5.6, and that will be the second half of Chapter 5. So 5.4 is focusing on something called polynomial division. And this is a lesson that I feel like I'm going to go through very slow at first. You may be in a situation where you may have to pause or rewind this video and listen to it again because it is something that takes a few times maybe to help it stick. And then as we get to later in the lesson, then things start moving quicker and we can kind of go through things at a little faster pace. So before we get into what it means to divide polynomials, I want to take you back to your days at, I'm going to guess maybe Dodge, like 4th or 5th grade, of how you did division with numbers. And I don't mean grabbing a calculator and typing it in and getting a decimal. I mean, how did you actually do long division? So here was the process. So if I wanted to see how many times 52 went into 37,525, you start off by saying, all right, does 52 go into 37? No, it does not. Does 52 go into 375? Yes, it does. Then you had to figure out how many times does 52 go into 375. And here's where it did help to either have a calculator or to kind of go through some mental math. So that's going to go in about 7 times. So when I put that 7, I'm going to put it specifically above that 5. It's very important where I put everything with this lesson. The next step was then to take the 7 and multiply it by the 52 that was out front. So you're going to take 7 times 52. Again, if you need a calculator, that's 364. And you wrote it down here. And then you subtracted that value. So you did 375 minus 64, which is 11. You then dropped down the next term. So you dropped the 2 down. And then you repeated the process. You figured out how many times does 52 go into 112. Well, 52 will go into 112 twice. You multiplied the 2 times the 52, which is 104. And then you subtracted. And then you brought down the last term. So the last term was 5. And you repeated the process one more time. We knew we were about done here because there were no more numbers to drop down. So you looked and see how many times does 52 go into 85. Well, it will go once. You multiplied 1 times 52. You subtracted. And we referred to this value as the remainder. Now, when you first start doing this, maybe in the younger grades, you put like a big capital R and you put like R33. But then you get a little more fluid in mathematics, and you realize that that remainder is 33 out of the original 52 that I was dividing by. So we were able to take that remainder and say, well, that's how much out of 52 I have left. So that is my answer to my division problem. So this, again, is the process of dividing long division with numbers. Well, now we're going to look at what happens when we divide polynomials. So now instead of dividing all numeric pieces, we're going to divide things that are polynomials. So here's what it looks like. You'll be given a polynomial and then asked to divide by another polynomial. So the first thing you want to do is you want to set it up with a division bar. So this part is going to go under the division bar. So 6x squared plus x minus 7 is going to go under the division bar. And then this part, we call it the divisor, what I'm dividing by, is going to go out here. If you are not a super neat writer, this is the lesson to maybe have a little change of heart, because I think the ability to keep things organized and neat makes these problems so much easier. And if you're kind of all over the place with your writing and not keeping things lined up, it can get very confusing. So that is just my, I guess, my caution. So here's how we start. We're going to start by looking at the first value here and the first value here. And we want to figure out how many times 2x goes into 6x squared. Another way to think of it is, what do I multiply 2x by to get it to be a 6x squared? So again, what do I multiply this by to get it to be this? It is 3x. The location that you put that matters. You're going to put the 3x here because this is the x column. This is your x column. This is your x squared column. This is your constant column. Once you get that value, you're going to multiply it by what is out here. So you're going to take 3x times 2x, which is 6x squared. And you're also going to take 3x times 3, which is 9x. So when you multiply, it actually involves distributing. Then you're going to subtract, and here's where I switch a lot of colors. When I subtract, it's going to make this a negative, and it's going to make this a negative. I love to use different color pens when I do this lesson. It makes so much more sense. When I subtract, this column will cancel, and then this column, I have x minus 9x is negative 8x. And then I'm going to drop down. So you are figuring out what you get when you divide. You're going to multiply by that value. You're going to subtract, which is going to involve changing signs. And then you are going to drop down. And once that is done, you repeat. So it's a lot of multiply, subtract, drop down, repeat. Multiply, subtract, drop down, repeat. So repeat. We need to figure out, what do I multiply 2x by to get it to be a negative 8x? Well, what I multiply 2x by to get it to be a negative 8x is negative 4. So I'm going to multiply negative 4 times 2x, which is negative 8x. And I'm going to multiply negative 4 times 3, which is negative 12. I'm going to subtract, which is actually going to make this into a plus sign and this into a plus sign. When you subtract multiple terms, it changes all the signs. This will cancel. The 8x, negative 8x will cancel. And I am left with negative 7 plus 12, which is 5. That is my remainder. The way I write it, though, is I put it as divided by your original divisor, 2x plus 3. So that entire thing up on top is your answer. We call it the quotient. It's your answer in a division problem. Since it did not divide evenly, since there is a remainder, we would say that it is not a factor. When we talk about factors, those are two things that multiply to get another. Because it did not divide evenly, we would say that 2x plus 3 was not a factor of it, because we are left with a remainder. All right, let me show you another one. Let me show you another two. So we have 4x squared plus 23x minus 16. And we're going to divide by x plus 5. So again, we start with those first terms. So we start with this term and this term. We need to figure out what I multiply x by to get it to be a 4x squared. Or what do I get when I take 4x squared and divide it by x? I get a 4x, and I'm going to put it in the x column. I'm going to multiply 4x by x, so get 4x squared. And I'm going to multiply 4x by 5 to get 20x. And then I'm going to subtract, and I love to do that in another color. I feel like if I don't do it in another color, I forget if I subtracted or not. That will cancel. I have 23x minus 20x, which is 3x. Keeping things in columns allows you to combine like terms. And then I'm going to drop down my negative 16, and I'm going to repeat. I'm going to see, what do I multiply x by to get it to be a 3x. So that's going to be a 3. It goes in the constant column. So 3 times x is 3x. 3 times 5 is 15. Subtract. Again, I'm going to put it in a different color pen. The 3x's will cancel. I get negative 16 minus 15 is negative 31. That is my remainder. So I will have a negative 31 over my original divisor, x plus 5. And there is my answer. This one is going to be a little longer. The reason I know this one's going to be longer is because I start with a higher power. The higher power that I start with, the more steps it's going to repeat. It's still the same steps. It's just they repeat more because there's more terms. And we're going to divide that by x minus 1. So I'm looking to see what I multiply x by to get it to be an x to the third. That's going to be an x to the second, x squared. So I'm going to put it in my x squared column. Oops, shoot, I didn't have my pen. Sorry about that. X squared. So I'm going to multiply x squared through. So x squared times x is x cubed. X squared times negative 1 is negative 1x squared, or just negative x squared. Subtract. So I need to change my signs. Then that and that. That is going to cancel my x cubes, and I'm going to have a 3x squared plus 1x squared is 4x squared. Drop down my next term and repeat. So x, trying to figure out what I have to multiply that by to get 4x to the second. It's a little too dark, sorry. There we go. So that is going to be 4x. So I'm going to put a plus 4x times x is 4x squared. 4x times minus 1 is negative 4x. And again, I'm going to subtract, so I'm going to change signs. So that's going to be negative, that's going to be positive. My 4x squareds cancel. I get negative x plus 4x is 3x. Drop down the minus 3, so drop that all the way down. Repeat. So I want to figure out what do I multiply x by to get it to be a 3x. That's going to be 3, so plus 3. 3 times x is 3x. 3 times negative 1 is negative 3. When I change signs, this is going to be negative, this is going to be positive. So I end up with no remainder. What that means is that this was perfectly divisible. That means that this is a factor of the original polynomial because it divided evenly with nothing left over with no remainder. That is the ideal situation. It does happen a decent amount, but if that happens, you don't have to write anything in addition because there is no remainder. So I want to show you one that has a little extra step to it here. So this one, when you look at it, before you write anything down, so take a look at this. The one thing that's different about this, if you look at this piece here, I think we call this the dividend, what goes under the bar. It's missing a term. What I mean by that is it starts out as an x to the third, then it has an x to the second. It doesn't have an x to the first. The reason that's important is when I set up my division, I need to keep my columns lined up. So when I write my x to the third plus my 2x to the second, and I don't have an x, I still need to keep a column there. So to keep that column there, I put a 0x. It's basically a placeholder. It's the same thing we do when we write numbers. If I wanted to write the number 506, I wouldn't just write 56. This 0 holds the place of the tens and just says there aren't any tens. Same idea here. If you're missing one of your terms as you go down and from lower and lower exponents, put a 0 there to hold that place. That will allow us to divide and keep our columns in line. So it's more of an organization piece than anything else. So I want to see what I multiply x by to get x to the third. That's going to be an x to the second, which is going to go in this column. So x squared times x is x to the third. X squared times 6 is 6x squared. I'm going to subtract, so I'm going to switch pens. That's going to cancel. So 2x squared minus 6x squared is negative 4x squared. Now I'm in all sorts of colors. I'm going to drop down my 0x. So now I'm trying to figure out what I multiply x by to get it to be a negative 4x squared. So that's going to be a negative 4x. Multiply negative 4x times x is negative 4x squared. Negative 4x times 6 is negative 24x. I'm going to subtract. So let me change my signs. Oh, I should have done another color. Let me mark over that so you can see I did change my signs. So I end up with my 4x squared, my negative 4x canceling. 0 plus 24 is 24x. Drop down my minus 4. One more time, I want to see what I multiply x by to get it to be a 24x. That's going to be a 24 times x is 24x. And then 24 times 6, what is 24 times 6? 144. So plus 144. I'm going to subtract. I get negative 148. Yes, it's kind of a big number, but that's perfectly fine. It is my remainder. So negative 148 over the original divisor x plus 6. We would say that x plus 6 is not a factor because it did not divide evenly. We did have a remainder. That gives you the basics of how to do polynomial long division. There are some other techniques, but I wanted to go real slowly with these examples so you get a chance to see and then now practice this process.